I'm on the last week.
Okay, you guys are being recorded now. And inevitably, there's something in the background that shouldn't be in the background. There's nothing you can do about it.
Really?
Come on here, Nicole. Okay. Hello, everyone. I hope you can hear me. I've been asked to do the Kirby Bauer experiment. So I've got a couple students here that are going to carry it out right now. We're going to be using two different microorganisms for this. We're going to be using E. coli. So there's one of my E. coli broths. You can see the turbidity in it. Okay. And most of you probably don't have your epidermitis open yet. You see that? Still can't see it. Anyways, take it from me. This Staphylococcus epidermidis. And most of you already know how to open these, but I have to do it, so you're going to get to see it again. Okay. So I'm going to need my alcohol lamp. Everybody see that? Kind of. There we go. And what we're going to do is we're going to take the top of this. It's a lot easier to do with gloves because it hurts your hands less. Take the top off. Move it down one side. Like so. Open. Take off the surrounding aluminum. There it is. And now what we're going to do is we're going to put a little bit of broth in there. So here's my broth, nutrient broth. And I'm going to cheat, guys, because I can. I use a pipette. So here's my tube. I'm going to unscrew it, flame it, and take out my liquid out of there. And I'm going to do that a couple more times because I'm only doing 200 microliters at a time. Here's my ampule. I can flame that. Add my liquid. And I'm going to do it one more time. Otherwise, my pellet is not going to dissolve in there. So I'm going to throw away my pipette tip here. Everybody see that? That's my hairy arm. 1, 2, 3. 30-degree angle. Suck up our fluid. 1, 2, 3. Cover it. We're going to add our solution to our vial. Cap it. Okay. Jeff is having an aneurysm. I'm going to try to see if I can get him to do it outside. Okay, so there's my, I don't know if you can tell, but there's my pellet right there. Here's my liquid at the bottom. And I got to get that pellet into the liquid. Okay. Now, I'm going to cheat again because I have a vortexer here. That allows me to get the pellet into solution. But I got to work that pellet in there, otherwise my cells are not going to go into the liquid. Struggling a little bit. There's my pellets there, so at the top. We're getting there. And we've gotten there. My pellet has disappeared. It's all gone to liquid. That's beautiful. And now I can take another pipette, suck that out of there, and put it into my nutrient broth as Staphylococcus epidermidis. Okay. One, two, three. I'm going to take out about, I'm going to try to take out all of it out of there. It looks very nice and turbid, so I've been successful. Thank you. That's important, isn't it? There we go. I took everything out. All right. So now I've newly activated Staphylococcus epidermidis. I'm going to vortex this. You don't have a vortexer, so what do? You tighten the cap and you shake vigorously. Okay, you want to get a homogeneous solution is what you're trying to do. Me, I have a vortexer, so I'm going to cheat. There's my homogeneous solution. It looks really, really good. Okay. Now, what is the overarching principle of this experiment? What we're going to do is we're going to take a gram-negative organism, which is E. coli, and a gram-positive organism, which is your Staphylococcus epidermidis, okay? And then we're going to use 2 antibiotics. We're going to use bacitration, okay? So bacitration is a beta-lactam antibiotic. And what this is going to show is that, well, hopefully what this is going to show is that bacitration is going to inhibit the gram-positive organism, Staphylococcus epidermidis, a lot better than the gram-negative organism, E. coli. Okay. By contrast, tetracycline is not a beta-lactam antibiotic. What this does is it stops protein synthesis. If you go back to your antibiotic chapter and look that up, you'll notice that tetracycline means 4 rings. And what that's doing, that's describing the shape of the molecule. And what the molecule does is it attaches with the ribosome, inhibiting the production of any protein. So, because protein synthesis is essential to any living organism, hopefully the tetracycline will inhibit the growth of both gram-positive and gram-negative organisms. So that's what's going on here. We're trying to contrast theory and application. Okay, so to recap, macitration is supposed to inhibit gram-positive organisms. In our case, Staphylococcus epidermidis. Tetracycline should be able to inhibit all types of organisms, both gram-positive and gram-negative. So hopefully our results will convey that. And then, of course, we have a paper, which is our negative control. So what we're going to do, Kirby Bauer is a very specific test that's done in hospitals and in clinical environments. And every aspect of the test is standardized. The media that's used is a specific media. The height of the media is specific. The concentration of the broths is standardized. The concentration of antibiotics in the discs is also standardized. And in this experiment, we're not standardizing any of those things. So this is kind of a bull in a china shop kind of way of doing this, but it should still give us dependable results, okay? Ideally, we need the right concentration here, the right media, and the right height of the media. We're going to use a nutrient agar plate. We're going to use the broths that, well, obviously the one that I just made from epidermidis. And the other one, what I did is I chose one of the E. coli dilutions that has a similar turbidity to the epidermidis that I just rehydrated. That way, even though the test is not standardized, it should be pretty close, okay? So, now that we've gotten that out of the way, this is actually, like I said, a pretty simple experiment. I need to label my Petri dishes so I don't forget which one is which. Labeling on the media side of the Petri dish. We need to put E. coli on one of them. And we need to put Staphylococcus epidermidis on the other one. Just like so. Now, I'm going to start with my E. coli. And what I'm going to do is I'm going to take one of these swabs right here. I'm going to open them aseptically. Like so. I'm going to take one of the swabs out. I'm going to take my tube of E. coli. I'm going to shake it one last time. That's code for vortexing. With the back of my hand, I'm going to take the cap off. I'm going to flame it. 1, 2, 3. I'm going to stick my swab in there. I'm going to flame it. 1, 2, 3. I'm going to cap it and put it away. And then I'm going to swab this dish aseptically. What that means is I'm going to move the lid up. I'm going to move the lid up just a little bit. And I'm going to swab across like so. Then I'm going to turn it 90 degrees. And I'm going to swab it again. I need a good carpet of cells to grow. I'm going to tell you that's not enough. So I'm going to go back to my E. coli and aseptically, I'm going to add more broth to this guy. Okay. And I'm going to do it again. Turn 90 degrees. Do it again. How many times are you going to do this? You're going to do this until you feel confident that you have a well-defined cover of E. coli on the bottom of this Petri dish. Because if you don't, then you're not going to be able to see the zone of inhibition. Ninety degrees. Do it again. Okay, I've done it 3 times. I still don't feel good about it. I'm going to do it one last time. Turn it 90 degrees. Okay, I'm feeling pretty good about this. I think I have a very good carpet on here now. So now that I've done that, I'm going to go ahead and put my discs on there. Okay. So I'm going to use my little tweezers here. Use my little tweezers. And I'm going to grab my concentration first. Why? Why not? And the discs have letters and numbers on it. The letter is what the antibiotic is. The number is a concentration. So, needless to say, you need to put the lettering face up, otherwise you're not going to know what's what. Okay? So without letting it go, and open the lid a little bit, I'm going to put it just between the center and the edge of the plate right there. You see that? You see that? Oh, because my big fat hand is in the way. How about that? You guys see that? Kind of?
Better.
Better. Okay. Now what I like to do is I like to press on it a little bit so it doesn't fall. Okay. Make sure that you touch only the top of the antibiotic disc and not the media, because the media has E. coli. And remember, I have to use these same tweezers for the other dish. And I don't want to cross-contaminate. So I'm going to put my little tweezers here on my green bag. And now I'm going to take my tetracycline. So if I can find it, there it is. There's my tetracycline. You can flame the tweezers, as a matter of fact. Nicole asked a fantastic question. Can you flame the tweezer cells? Or yes, you can. That's a great idea. Okay. And then this is a lot easier to do on camera. I don't know. So there's my tetracycline. I'm gonna grab one more little guy in here. All right, grab one disc. Easier said than done. We can do it. We can do it. We can do it. There we go. Grab my disc. There it is. We'll turn this. We're going to put it right about there. About equidistant. Or right about there. Remember, we're going to touch only the top of it. Only the top of it. You see it? Okay. All right. And then we'll do our negative control. Okay, let's see if I can do that equidistant. That'll work. Close enough for government work. Okay, that's one down, one to go. If you can do one, you can do the other. I can stop watching this right now, or you can watch me struggle to do the other one. What do you guys want to do? Do you want to try one of them?
Yeah.
Do it all.
Come over here. Come over here. So Nicole's going to try to do one of them. Okay. So there's your petri dish. And let's see if I can get closer to you. I'm sorry, Nicole. I gotta make you famous. Very good. That's looking good. So I did E. coli. You're gonna do Staphylococcus epidermidis.
This one?
No, that's the one that I did.
Okay.
Am I wrong about that? I did E. coli. This one is E. coli.
Okay.
You're going to do Staphylococcus epidermidis. There you go. Now I get to watch you. Just make sure you're in frame. Okay, but I will do something else. I'll make an effort to assist you. There you go. Very nice. You've got better technique than I do. That's typical. Students are better than I am. It's all right. I've gotten over it. There you go. Nicely done. Now, I was way over there, so I couldn't see my streaks. But you should be, don't go too high. Otherwise, we'll ruin our aseptic technique. But from there, you should be able to see your streaks a lot better. Okay, cover it, and then do it probably two or three more times. The biggest mistake that you can do with this is not have a carpet. If you don't have a carpet and you don't have a good zone of inhibition, you're not going to be able to get good results. This is the first time I've had students in a lab. I think I like it better. It's so weird to talk to yourself.
Yeah.
You know, or talk to an audience that's not there. Very nice. Nicole's not getting paid for this.
Oh, wait, what?
Very nice.
That good or another time?
That's looking pretty good.
Okay.
So let's put your thing in waste. There we go. And let's see. Here's your 3 antibiotic discs and your tweezers. I have a stamper that I use in my face-to-face labs. I gotta tell you, I insist on being spoiled.
What's a stamper?
Oh, I'm gonna show you. I want everybody to see it so you can go, really? With the stamper, you put it on top of the Petri dish, you push it down once, and it drops 6 antibiotic discs simultaneously, equidistantly from each other, aseptically.
Wow.
And yeah.
That would be nice.
Oh, it's beautiful. Instead of the so-called tweezer approach that we're doing here. They're a lot better at dropping them too. Mine drops and rolls. Oh, you're being complacent. Okay, now we have to do something different here. And that's the fact that we have to use parafilm. You guys don't have to use it, but we're going to put this in our incubator at 37 degrees Celsius. And if we don't put this parafilm around the Petri dishes, they'll get dried out by tomorrow. So this is a precaution we have to take here. Hello. Really? Nicole's already done. I'm still struggling with mine. There you go.
Thanks, sir.
I give it to Jeff. He can do it. Very nice. So now we'll put that in the incubator. And yeah, we're done. We're done with that. So we're actually done with the exercise, but I want to show off a stamper. So let me do that real quick. Because imagine that you're in a hospital environment. You're not going to have a whole bunch of people with tweezers putting these discs on there. That would be insane. Nobody would ever get anything done. So instead, you use a little, what's called a tamper. What?
It's not on camera.
Oh, I know.
Okay.
Oh, thank you for telling me. I'm going to put it on camera in just a second here. Just got to put one more. There we go. So, okay, I'm going to push Jeff out of the way. Here's my Petri dish. Oh, almost forgot. I need a clean environment. I need a septic environment. What do I want? I would like a page. That's right. Okay, a little towel here. I'm going to put my Petri dish on top of it. Anybody see it? Thank you, Nicole. Here's my Here's my tamper. Is that cool? Okay. And what I do, go ahead to take the lid off.
All the way?
Yep. Put the lid back on. Bam, look at that bad boy. So now, tell me if you can see that. See all the discs they put on there? Now that is fun. So on this petri dish, I'm testing 1, 2, 3, 4, 5, 6, 7, 8 different antibiotics. And that's the way it's done. And that's how I use a tamper. I won't tell you that these cost $500 a piece.
Is that what they would use in like a hospital
Yep.
to test which antibiotics?
Yeah, and actually, another good question. So Nicole is asking, is this what you would use in a hospital? And it's close. In a hospital, if you were to do a Kirby Bauer, the petri dish is actually bigger and the tamper is bigger. So you can test up to like 18 different antibiotic discs at the same time. And those tampers actually cost less because that's the standard tamper that's used in clinical environments. This one is more expensive because they make less of them, and the only ones that use them are academic environments like ours. But isn't that cool? Very, very neat. Okay, that's it, ladies and gentlemen. Thank you. Thank you, Jeff and
Nikki.
Nick.
Bye, guys.
Nikki. Thank you, Nick.